Lesson 11.7, Trigonometric Ratios. This is probably something some of you have seen before, not necessarily all of you. And the number one thing to remember when studying trigonometry, or just trig, is SOHCAHTOA. Now, it's an acronym. It doesn't mean anything. I've been told that it means an Indian princess's name. It doesn't mean anything. It just stands for things. So, there's three ratios. The S stands for sine. We write it as sine, and it is equal to, in a triangle, the opposite over the hypotenuse. And you might wonder what that means, and I'll show you in a little bit. So that's SOHCAHTOA. The C in ka stands for cosine. And again, we never write cosine, we just write COS. And A stands for adjacent over hypotenuse. Adjacent over hypotenuse. And so it's just a memorizing mnemonic. T stands for tangent, which we write as tan, and it's equal to the opposite over the adjacent. So opposite over adjacent, what? Hypotenuse of what? Well, obviously we have a triangle. So we'll show you in the next step. And SOHCAHTOA I'll probably rewrite in several problems, so try to have it memorized. So like I said, do you have any idea what that means? Well, what it means is that we have a triangle with a right angle. Has to have a right angle. We call the points with the big letters and the sides across from with the small letters. So if I say sine of A, I'll rewrite it here, SOHCAHTOA. We'll keep it, actually I'll write it down below, so we'll have it for the next problem too. It's opposite, and we're looking at angle A. So opposite of A is little a over hypotenuse. And B is a hypotenuse across from the right angle. Cosine of A is equal to adjacent C over hypotenuse. And tangent of A is opposite A over adjacent C. So these are just ratios. And the reason we use these ratios is they pop up all the time, so we're just going to shortcut. Instead of saying, oh, what is the opposite over adjacent, we just say, what's the tangent of the angle? We could also do tangent of angle C, sine of angle C, cosine of angle C. We will not work with B because that's the 90-degree angle. So we know we have a right triangle. That means only one other angle is necessary. So we can set up all these trigonometric ratios in our calculator when we use a TI or any other one, and they're already preset because they're all similar triangles. They have a right angle plus we know one of our angles. After a while, this becomes second nature, but at first it's very strange, so we'll get there. So here's a triangle. There's three sides, and go ahead and find the angles for sine of R, cosine of R, tangent of R, and sine of T. I'm going to run out of room here. I'll put it down here. Sine of T, cosine of T, tan of T. The first thing we have to do is finish a triangle. We have a side here that's missing. I happen to know that this is a triple, but we'll write it out. 12 squared plus, call it A, call it B, call it little t. T squared equals 37 squared. If you do the math on that, you'll find out that t equals 35. So now we look at sine of r, opposite over hypotenuse, 12 over 37. Cosine of r, adjacent over hypotenuse, 35 over 37. Tangent of r, opposite over adjacent, 12 over 35. Sine of t, opposite over hypotenuse, 35 over 37. Cosine of t, adjacent over hypotenuse, 12 over 37. Tangent of t, opposite over adjacent. This might be a good time to pause the recording and take a look at sine, cosine, tangent for both angles. See if you see any patterns. I'm not going to go into them now, but that's where the whole study of the concept of trig comes from. It gets very complicated. There's a lot of things that overlap and that back each other up. So, good time to check that out. So, let's do some problems. This one's a little trickier. Got a triangle with 5 and 10. And let's go with LMP. And I want to know, what is the measure of angle P? Well, we look at P, and we say, well, what do we know? We know the opposite and the adjacent. That looks like tangent to me. So tangent of whatever angle P is equal to 5 divided by 10, also known as 0.5. This is where we need our calculators. There's no way to do this without a calculator unless you have a table and you want to guess it off of there, but almost everybody does this with the calculator. So here's how we solve it. If tangent of P equals 0.5, we can rewrite this as P equals tangent to the negative first of 0.5. So we put in our calculator. Second, tangent to the negative first, 0.5. Enter. It says 26.6 degrees. So here is 26.6 degrees. Since we know that the triangle adds up to 180, we also know that angle L can be solved from here. Although we didn't have to here, we'll do it anyway. So we get 90 plus 26.6 plus the measure of angle L equals 180. Subtract them off, we get measure of angle L equals, that's an angle followed by an L, 63.4 degrees. You can tell if you did it right if 63.4 plus 26.6 adds up to 90, which it does. So, when we want to know everything about a triangle, we call it solving the triangle. So here's another triangle. Give it some data. Call this 38. Call this 12. Call this 38. Give it some letters again. Let's go with ABC. Keep it simple. 38 degrees. And solve the triangle. Well, first thing, let's find angle C. It's 90 degrees minus 38 degrees. Don't have to go all the way to 180 because we have a right angle. Equals 52 degrees. Now we want to find the legs, so we can say pick any one we want. Let's go with sine, doesn't matter, and let's go with angle A. Sine of angle A is opposite, which is A, over 12. And I can erase A because we actually know A. It's 38 degrees. Multiply by 12. Cancel. A equals 12 times sine of 38 degrees. 12 times sine 38. By the way, very important, when you do this, make sure your calculator is in degree mode, which it is. 7.4. So this is 7.4. Now at this point we have an option. We can do 3 or 4 different things. We could do a squared plus b squared equals c squared. We could do sine or cosine of different angles. Let's do cosine since we've already done sine. And let's use 38 degrees again. And that would be c over 12. Again, multiply by 12. C equals 12 cosine of 38, 9.5. So we have 7.4 squared plus 9.5 squared, and it should equal 12 squared, which is 144. So let's check it out. 7.4 squared plus 9.5 squared. 145. Pretty close. Definitely within a rounding error. That's called solving a triangle. Takes some time. And last but not least, trig problems really look good in applications. Some of the better applications we'll see. So here we go. Plane's 1,000 meters in the air. So that's this right here. And we see that the angle has 40 degrees angle of depression. Now, this is a math thing where the teacher tries to mess with you. Always draw it down on the bottom because these degrees are equivalent based on similar triangles, based on alternate interior angles of parallel lines, but don't even get into it. Just simple enough. And now we want to find out how far away the runway is. And that's this distance right here. So we need the hypotenuse. So cosine is adjacent, doesn't help us. Tangent is opposite over adjacent, doesn't help us. Sine is opposite over hypotenuse, that helps us. It's called the hypotenuse H. Sine of 40 degrees equals 1,000 meters over H. Multiply by H, divide by sine of 40. H equals 1,000 over sine of 40. $15.56 we'll go with. Since we're dealing with meters, meters. Very tricky stuff. Definitely take some practice, get good at it, but we'll keep it simple for the time being. Go forward from there. Good luck.